Hi guys, welcome to the ride. So in today's video, we're going to answer random problems for machine design, meaning there are no specific topic for today's video. So magsasagot lang tayo ng mga kung ano-anong problem from different topics under machine design, and of course, yan, samahan niyo ako with your calculator. Okay, so tara, let us start this. Wala ako ng tinta. So yan, we have the 4 questions here and I'm going to answer this for separate slides. So yan, start tayo sa number 1. So what is the approximate stress area of M20 by 3 volt in square millimeter? So this topic is under threaded members or fasteners that involves bolts and screws. So we all know that we have approximate formula for a stress area of a bolt. Pi over 4 multiplied by D minus 0.9382 pitch squared. So if you are going to have your diameter here in mm, and your diameter here is your bolt major diameter, and your pitch here is pitch in mm, at ang magiging stress area mo daw, ang unit ay in square millimeter. So perfect for this question. Exactly, ano na lang yan, direct sub. So kailangan na lang natin mahanap ang D and letter P. So we all know that in threaded specifications, kapag metric ang usapan, ang M20 by 3, yung 20 mo dyan, yun yung major bolt diameter mo, at yung 3 dyan ay yung pitch mo. So this will become a direct sub. So stress area is equal to pi divide 4, 20 minus 0.9382 multiplied by 3. Tapos yung loob niyan ay square mo lang. So in order for you guys to memorize or just learn the basic principle, we all know that kapag ang circular, may area na pi over 4 d squared. So parang ganun lang siya. Pi over 4, ito yung d squared mo. Okay, so ang stress area natin in square millimeter will be 0.9382 times 3, 20 minus answer nun, square times pi divide 4. And there you have it. We have the 231.96 square millimeter. So meron din tayong stress area sa inches squared. Just a little recap lang or review. So we have the pi over 4. Diameter ulit, 0.9743 naman, engineer. Ayan guys, so square. So your diameter is in inches and your pitch is in inches. So magkakaroon ka na naman ng stress area sa inches squared. So that's another formula for stress area for English unit. Pero syempre that will be depend also again on a thread specification. So ito kasi pang metric yung thread specifications na to. So I will upload another video later about that. Pero ito, ang gusto ko lang kasi is to answer random problem. Okay, so that will be for the first item. So we have the second item here. A 75 millimeter diameter shaft is transmitting 300 kilowatts at 600 RPM. A flange coupling is used and has 6 bolts, each 18 millimeter in diameter daw. So find the required diameter of the bolt circle based on an average shearing stress of 27.5 megapascal. So basically, this topic is under the coupling design. So ayan, solve natin. So meron daw tayong 75 mm diameter shaft is transmitting 300 kilowatts at 600 RPM. So find the required diameter of the bolt circle. So bolt circle is designated by DBC. And we all know that torque in the coupling design is force times DBC divide 2 times the number of bolts. So kung ito yung coupling mo or the flange coupling, ayan. So of course meron dyan torque, meron dyan forces isa-isa. Yun, basta yun. Tapos meron ka number of bolts dyan. And ang tinutukoy na DBC is ito, yung bolt circle. Okay? So para lang siyang guys, force times radius or force times diameter over 2, lalagyan mo lang ng number of bolts. Okay? So DBC. And insert the torque. So, maaari na ba natin makuha yung DBC dito? Hindi pa, kasi wala rin tayong torque and wala tayong force. So, meron tayong average shearing stress of 27.5 megapascal. We all know that the shearing stress for each bolt is F over A basic force divided area. So, that will become force divided by pi over 4d squared. So, at diameter mo dito is yung diameter ng bolt. Ayan. Bolt diameter. Okay, so i-cross multiply ko lang in order for us to have the force. F is equal to shearing stress multiplied area pi over 4 dB squared. So we may insert this force into this equation. So para isang type na lang tayo ng units or ng mga amount sa calculator. So our torque will become, ang force will become a shearing stress pi over 4 dB squared. So this is your F multiplied by DBC divide 2 times number of volts. So tingnan natin kung tama yung units. So this is megapascal or Newton per mm squared times dB squared. So this will become mm squared. Of course, cancel. And DBC is mm yan. So Newton mm dapat ang torque mo in order for our DBC becomes mm. So meron tayong given lahat. We have the shearing stress, the 27.5 megapascal. We have the bolt diameter of, where's that? And 18 mm. Ang number of bolts natin ay 6. So, DBC na lang talaga hinahanap. And syempre, wala tayong torque. So, gawa natin ng paraan para mahanap natin ang torque in Newton mm. So, we all know on our machine design days, meron tayong already na derived equation for the power and torque. So, meron tayong power dito. No? Meron tayong 300 kilowatts. Siyempre, pag may power, andyan na naman yung RPM. Ayan. And ayan. So, we all know that the power is torque times speed. Of course, meron tayong constant dito na kapag metric, we have the 9.549 times 10 raised to 6. Para magkaroon ng power na kilowatt, kailangan yung torque mo is in Newton mm and your N or speed is in RPM and divide by this constant. So meron tayong power in kilowatts which is the 300. Meron naman tayong RPM na 600 and ayan. Makakuha na tayo ng torque in Newton mm. So ayan. Ang torque will be power is 300 times 9.549 times 10 raised to 6 divided by 600 and we have it 4,774,500 Newton mm. So wag magulat kung malaki yung torque kasi malaki nga naman yung yung power which is 300 kilowatts. Okay? So meron na tayong torque. Ayan. So ayan, direct sub na lang tayo. So dito tayo. Parang hindi na tayo magbura, no? So ang torque natin is ayan, 4,774,500 is equal to average stress 27.5. Tama? Times pi over 4. Diameter ng bolt, 18 squared. Times DBC. Divide 2. And multiply by the number of bolts which is 6. So yun, makukuha na natin si DBC. So yung answer mo, huwag mo na barahin yung torque kanina. Times 4 divide pi. Divide 27.5. Divide 18 squared. Times 2 divide 6. And we have it. So we have our 227.42 mm. Okay, so that will be for the second item. So, ayan, tapos tayo sa coupling design topic na to. So, we're going to proceed with the third. So, ayan naman. So, determine the bursting steam pressure of a hemispherical steel shell with a diameter of 100 inches and made of 0.635 meter thick steel plate. The joint efficiency is 70% and the tensile strength is 60,000 psi. So, ayan, pagkabasa po lang ng problem, alam natin na ito ay under the pressure vessel. So, in order for us to solve pressure vessel, alam naman natin na meron tayong thin and thick walled pressure vessel. So, meron tayong thin, matatawag nating thin vessel, yung pressure vessel kapag thin walled, kapag yung ratio ng thickness over its diameter is less than 0.07. Kapag thick walled naman, ayan, of course, it's greater than 0.07. So, ayan. So, kailangan malaman muna natin yung ano niya, yung restriction niya. So, meron tayong thickness na 0.635. So, convert muna natin sa inches. Kasi lahat ng value ay naka-inches, tas PSI pa yung pressure mo, which is pounds per inches squared, yung PSI. So, thickness is 0.635 meters. So we all know that 1 meter is 3.28 feet and 1 feet is 12 inches. So that will become 0.635 times 3.28 times 12 inches. And you have the 2.5 inches. So the ratio T over D is 2.5. So nasa ng diameter natin dyan? So ayan. Nagsabi diameter po 100 inches. 2.5 divide 100 and that will be 0.025. So matic, it is less than 0.07, so it is thin walled. Ito kasi thick. So it will become thin walled. So we all know that meron tayong formula na in thin walled pressure vessel, lalo na kapag hemispherical, ayan, meron tayong tensile stress equal to PD over 4 times thickness times the efficiency. So efficiency is E. So ayan, PD over 40. Lagi yan kapag spherical. So, in order for you to have this tensile strength na maging PSI, of course, your pressure or your bursting steam pressure dito or bursting pressure is in PSI also. Your diameter is in inches and this will be in inches. So your letter E is dimensionless. So cancel. Ayun, tama, PSI. So our tensile strength here is 60,000. PSI is equal to bursting steam pressure natin. Yun ang hinahanap pala. Determine the bursting steam pressure times the diameter. Ano yung diameter natin? 100 inch. Divided by 4, multiplied by the thickness of 0.025 inch times 0.7 kasi 70% yun. So ayan, that will do it. So cancel yung inches mo rito. Of course, ang matitira is PSI. Our bursting steam pressure is in PSI na yung sagot. So ayan, cross multiply 60,000 times 4 times 0.025 times 0.7 divided by 100. That will do it. You have your 60,000 times 4 times 0.025 times 0.7. Okay, so divide by 100. Yeah, so we have 42 PSI. Tama ba? 60,000 PD, 100 inches, 4 times thickness times 0.7. No. Kaya pala mababa. This thickness is 2.5. Yung ratio pala yung ginawa ko kanina dito. So, sorry. So, 2.5. So, that will become 60,000 times 4, 240,000 times 2.5 times 0.7 divide 100, and that will do it. 4,200 PSI. Okay. So, that will do it for our pressure vessel problem here. So, last, number 4. A hollow iron pipe to be designed as a column has an outside diameter of 240 mm and is subjected to a force of 80 kilonewtons. So find the pipe thickness if the compressive stress is limited to 16 megapascal. So this is an easy one problem. So alam natin ito is just a basic stress problem. We all know that S is equal to F over A. So ang compressive stress, sabihin natin designated by SC, ang hinahanap is pipe thickness. So kunyari, ito yung pipe cross section mo. So if we have the outside diameter and the inside diameter, so ito yung thickness niya. And based on the drawing, ang major diameter mo raw outside is equal to inside diameter plus twice ng thickness. So magiging thickness is equal to capital D minus small d divide 2. Okay? So syempre kailangan muna natin makuha yung big and small diameter. So meron tayong meron tayong stress na 16 megapascals or 16 newton per square millimeter is equal to F. So 80,000 newton. So ayan yan. Divided by since it is an hollow, we all know that the area of hollow is pi over 4 parenthesis d squared minus small d squared. So magkakaroon tayo ng 80,000 divided by pi over 4, 240 squared minus d squared. So makakuha na natin yung small d dyan. So given din pala yung capital D which is 240 mm as your outside diameter. So lalabas yung D, may given yung capital D, and yun, malalaman na natin yung thickness. So this is a direct sub. So 80,000 divide 16 times pi over 4. So 240 squared. So yan. So direct sub nyo na lang din. So yan, magkakaroon tayo ng small d na 226.35 mm. Okay. So my advice to you guys is that kapag may gantong problem, pwede rin namang anong tawag doon? Shift solve. Pero ipunin nyo muna. Pwede rin namang 240 squared minus d squared is equal to 80,000 divided by pi over 4. Tapos ipailalim nyo na si 16. So makukuha nyo yung amount niyan. Tapos transpose lang. Minus mo sa 240 squared. Minus amount nito is equal to d squared. Of course, yung value nun square root. So magkakaroon tayo ng 226.35. So that will do for thickness. 240 minus 226.35 all over divide by 2. And meron tayong 6.8 mm. Okay, so ayan. That's all guys. Nakasagot tayo ng 4 na items. So parang nag-refresh lang tayo for the topics of machine design. Yun, salamat sa pagsama sa akin sa pag-solve ng problems, and if you want to try more problems for machine design, I posted a month ago or 2 months ago 100 item quiz for machine design. So search nyo na lang sa page natin na Derive, and meron na rin yung solution manual. At pag may hindi kayo naintindihan, just PM us directly. So salamat sa pakikinig, and again, see you sa mga next videos natin. Thank you and God bless.